A ball tossed upward from a bridge just missed the bridge on the way down and lands in the water below. The bridge is 24 meters above the surface of the water. The elapsed time for this motion is 3 seconds. Determine the initial speed of the upward. So there is a bridge and it is 24 meters tall, and this is surface of water, and the ball was tossed from a bridge to the surface of the water. So the height is 24 meters and the time is 3 seconds. And on the surface of the water, the velocity is gonna be 0. So we are going to find the initial velocity, and we are going to apply this equation. So the total 24 meter tall and so the initial velocity is gonna be 7 meters per second. The driver of a car moving at 20 meters per second noticed the light has changed to red. When the driver applies the brakes, the car experiences a deceleration of 10 meters per second. How far will the car travel before it stops? So we are going to apply this equation. "24 meters per second square," and this is going to be acceleration. So the distance is going to be 20 meters per second. Determine the magnitude of acceleration from 2 to 3 seconds. Determine the displacement from 3 to 5 seconds. Determine the magnitude of acceleration from 3 to 5 seconds. So we are going to find the displacement from 3 to 5 seconds. So this is time and this is velocity. So we can find this by finding the slope. So the magnitude of acceleration means that acceleration is the slope of this graph, and acceleration means derivative of position over this time. is this is the derivative of acceleration, and this means the slope of this graph, and there is first of all, we are going to find the area. So the area means displacement, and so this is gonna be answer of the first question. This is gonna be second answer of the second question. It means the slope is we are going to apply this to this, so we can find this is 3 and 10, and slope means rise over run. So the answer of the second question is going to be minus 2.5 meter per second. How high is the ceiling in a school gymnasium? If a volleyball thrown upward from the floor at 10 meters per second barely touches the ceiling before returning the ground. So it means the volleyball was thrown to the ceiling, and its velocity is going to be 10 meters per second. And the final velocity is going to be 0 meters per second because it is going to be touched the ceiling. So we are going to apply this equation. So the distance is gonna be 5 meter. A mass undergoes a constant acceleration from rest at 4 meters per second. What is the displacement of the mass at the end of the 10 seconds? So the initial velocity is gonna be 0 per meter per second, and the acceleration is 4 meter per second. The time is 10 seconds, so what is the distance? We are going to find the distance. So we are going to apply this equation. So the answer is going to be 2000 meter. A mass initially at rest experiences a uniform acceleration. During time interval t, the mass is displaced a distance x. What is the displacement of the mass when the ellipse time doubles? N equal to t. So we are going to apply this equation. So the initial velocity is 0 meter per second, and the distance is gonna be this, and we are applying 2t to this, then this is gonna be 4. So 4d is gonna be the answer. A runner is training on an oval-shaped track, but each lap has a length of 400 meters. The runner maintains a constant speed and completes 2 laps, returning to the starting point in 100 seconds. What is the velocity of the runner for this time interval? Displacement is the distance between initial and final position of an object. When an object returns to its original position, displacement is 0. So velocity is distance over time. It means 0 over time. So the velocity is gonna be 0. A boat with a speed of 4 meters per second we cross a 40 meter wide river that has a current of 3 meters per second. The boat aims directly across the river. How long will the boat take to cross the street? How far downstream will the boat drift as a result of the river currents? So this is the river and this is the direction of the currents. So this velocity is going to be 3 meters per second. This is the boat and this is going to this direction at 4 meters per second. And the width of the river is 40 meters. So we are going to find this diagram. This is x direction and this is going to be y direction. So distance is equal velocity multiply time, and the width is 40 meters. and this is equal to velocity multiplied time. So time is gonna be 10 seconds. Also, we are going to find the distance. So distance equal to velocity time. Velocity multiply time. So we will apply this answer to this, so we can find 3 meters. So the distance is gonna be 3 meters. This is 1, this is 2. A ball thrown horizontally from the edge of a 20-meter structure and 3 meters from the base of the structure as shown. Determine the speed at which the ball was shown. So we are going to find the velocity and we are going to apply this equation. And this is 0 meter per second. This is going to be 0. So this is same with 1/2 time acceleration time and this equation. The time is gonna be we are going to apply this 2 seconds to this. So the velocity is gonna be 15 meters per second. The diagram depicts a projectile launched from point A with a speed at angle of theta above the horizontal. The projectile reaches its maximum height h at point B. The projectile impacts the ground at point C are at the same height. The total time of flight from point A to point C is t seconds. Determine the speed of the projectile at B. Determine the speed of the projectile at C. In projectile motion, Vx gonna be V times cosine theta and Vy is gonna be V sine theta. And maximum height, the velocity component of velocity will be 0. So vi gonna be 0 and velocity gonna be vx. The horizontal component of velocity is constant during the flight of a projectile, and the magnitude of velocity is speed x. So v is equal to v cosine theta. This is the answer of the first question. At any 2 points having the same height, the projectile will have the same speed. Point C has the same height as point A, so the same height and same speed. So speed in this point is equal to speed in this point. Velocity is the same at this point and this point. So this is the answer of the second question.